I'm Nathan Henderson from the Department of Physics, University of the West Indies, and more specifically the UMONA Alternative Energy Research Group. And we have a number of exhibits today that show how you can use renewable energy, how we can use renewable energy in our everyday lives. One of the exhibits that we have to reducing energy wastage is shown right here. This involves what's known as a Peltier thermoelectric energy generator, and we have one setup right here which is converting waste heat to electricity, and we have one here that is converting electricity into a temperature difference. And this is Dudley Williams from the Department of Physics as well. He is lighting a candle which is going to heat up 4 of these thermoelectric energy generators. As they heat up the generator, which is made of a semiconductor material, it begins to generate electricity. And we can see that electricity is being generated as each of these 4 lights turns on. And the voltage is proportional, the voltage or the amount of electricity is proportional to the temperature difference. So one side of the Peltier is hot. The other side, which is cooled by the water in this container or this basin, is very cool. So you notice that the yellow light came on, which means as he cools down the side, more energy is being generated. And if we plug in a cell phone to this module right here, the cell phone comes on, right? And it's being charged using energy from the candle alone. That's the only energy being used to charge this. Right? We have a number of other exhibits as well. Among the research we're doing in the group is the use of drones to survey solar farms for faulty solar panels. Alright? How do we tell if a panel is faulty? Simple, thermal imaging. If you look at a faulty solar panel using a thermal imaging camera, you can actually see different colors on the image that correspond to hot spots, areas where the panel is not performing. And these can indicate that the panel needs to be replaced, removed, or repaired. On the far end of our exhibit, we have a sample of a solar energy setup. And what this shows you is the major components that would be needed to create a standalone solar system. Right? This battery is charged using solar energy, and so we would have connected it to some solar panels during the day. They charge it up, store the energy, and during the night or throughout the rest of the day, when you want to make use of that energy, it's available on demand. And that energy can be used for lighting, all right? Using these DC bulbs. And these DC bulbs don't use a lot of energy. Right? They actually use about 1/10 of the amount of energy that a regular light bulb would have used. Using an inverter and these components here, we can convert the stored energy to 110 volts, which is the same voltage your sockets provide. So that's it. This is the work that we do in the Alternative Energy Research Group. We're all about energy sustainability, energy management, energy efficiency.